Hello. So in today's video I am going to talk about the nomenclature of organic compounds containing polyfunctional groups. Poly means more than one functional groups when it is present. Then how to name the organic compound. So here what you have to do is, at first you should know the principal functional group, means the main functional group. Okay, now why is it important? Because the main functional group or principal functional group is written as secondary suffix, that is written at the end, and the least preferable functional group, or the functional group which is not principal, is written as prefix. Okay, so first you have to identify that what is the principal functional group and what is the prefix and what is the least preferable functional group, which will be written as prefix. Okay, so here this you can see here, this is written in the decreasing order of priority of some functional group. It is written the COOH is given the most priority, then after that SO3H, COOR, COCl, CONH2, CN, and like that. Okay, means if in an organic compound two groups are present, say COOH and COCl, these two groups are present, so we would write COOH as the principal functional group and we will write it in the suffix part, and the COCl, as because it is in decreasing priority, it has less priority, that is why it will be written in the prefix form. Okay, so I hope you have got this clear. So you should need to remember this, right? First COOH, then SO3H, COOR, COCl, CONH2, then CN, and likewise. Similarly, R, that is any alkyl group. R means alkyl group, so any alkyl group will be always written as prefix. Then C6H5, halogens, NO2, nitro, alkoxy, these groups are always written as prefix substituents, means you have to write it in the beginning, okay, if they are present. Now after that you have to number the chain in such a manner that the principal functional group gets the lowest possible number. Means if carbon chain is there like this and one functional group, that is OH group, is there, and one another functional group, per se CO group is there, okay, CO group is there, then the CO group will be written as what? It will be written as the principal functional group in the suffix, and you have to number the carbon in such a way that this principal functional group gets the lowest possible number. Okay, now after that you have to write the least preferable functional group as the prefix and the most preferable functional group as the secondary suffix, which I have already explained. Now if in case double bonds are present, okay, in case double bonds are present, then choose the longest chain that have both principal functional group as well as the double or triple bond. For example, if you have this type of organic compound, if you have this type of organic compound with you, okay, CH double bond CH2. Now you can see here you have one double bond and here you have one COOH group. Okay, so you have to select the longest carbon chain in such a way that the double bond and the functional group both gets the position. Alright, means we know that the principal functional group is COOH, so it will get the lowest possible number. So we will not go like this, okay, while numbering the organic compound. Rather we will go like this, 1 2 3 4. Why? Because here the double bond is also getting some number. We have to number like this, means the longest chain should bear the functional group as well as the double bond. Okay, now if more than one functional group of the same type are present, then their number is indicated by adding di, tri, tetra, and like that. So we will come to that later, but first of all, for polyfunctional group, let's see one question. Now here you have OH, CH2, 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 CO and CH3. Now clearly you can see there are two functional groups available over here. One is the CO, that is ketone group, and one is the alcohol. Okay. Now in the priority order, you can clearly see over here the ketone comes before OH group, means this is considered more important than the OH group. That is why we will write this CO group as the secondary suffix and the OH group as prefix, because it comes later in the priority order. So to write this, first of all I have to number the carbon chain. I have to select the longest possible chain. So we will begin from here, because CO is the principal functional group and I have to give the lowest possible number to this. So numbering this like that. Now in the 7th position, and you remember the mantra, that is first you have to write the prefix. Prefix is any alkyl substituent, alkyl group. Here no alkyl group is present. So in prefix we write the alkyl group or least preferable functional group. In case of polyfunctional group, the functional group which is least preferable, which comes later in the priority order, we write the name of that in the prefix. After that we write the word root. After writing the word root, we write primary suffix, which is alkane, alkene, alkyne, and the secondary suffix, which is the principal functional group. Clear? Now just see how to write the name. Now in the previous video I have explained the chart also, that in that chart we have seen that when OH group is present as a prefix, right, we use the name hydroxy for that. So that is why for mentioning that one hydroxyl group is present, we are going to write this 7. In 7th carbon one OH group is attached, so 7 hydroxy, then the prefix is done because no other alkyl group or least preferable functional group is present. So 7 hydroxy. After that word root, means how many carbon are there? 7. So heptane, hept, and it is an alkane because all single bonds are there, so heptane. Then with the second carbon we have in the second position we have the ketone group attached, so I will mention it 2-one. Okay, so this is how you are going to name the functional groups. Okay, polyfunctional group. Now just suppose you have another question. Always we should take 2 questions for example. In the another question which I have also mentioned in the previous video, this is the question over here. Right, now in this question you can also again see there are 2 functional group. One is the bromine group and one is the ketone, right? Now here the point is that bromine, I have already explained earlier also, that any halogen, bromine is an halogen, the halogens are always written as prefix, that is substituents. So I have to write, it is now clear that I have to write this bromine group as substituent and the ketone group as the secondary suffix. So we shall start writing the name of the organic compound, or you can say while writing the naming the organic compound. Now first of all, here if I start writing the name, numbering from here 1 2 3 4 5, right, and from here also I think same will be the case. The substituents, here we have 2 substituents attached, right, one is the Br group and one is the methyl group. So we have to choose that numbering where the substituents get the lowest possible number. In both the cases I think the numbering is still same, so we can take it from anywhere, right. Now first I have to write, there are 2 substituents, right, here bromine and one is the methyl group. So we will write it alphabetically. So first 2 bromo, for bromine, we don't write bromine, we write bromo as the prefix. You must have seen that. Then 4 methyl, okay. Then word root pent, and as because all single bond are there, pentane. Then in the third carbon we have one ketone group attached. So 2 bromo, 4 methyl, pentane, 3 on. This is the final answer. Now moving on to the next rule, that is, if more than one functional group of the same type are present, then their number is indicated by adding di, tri, etc. Okay. Now for example, you have this type of organic compound with you. Okay. So now here this is the first carbon and this is the second carbon, right? Now कहीं से भी numbering तो यहाँ से वहाँ से एक ही बात है. Now 2 carbon are there, so here we are going to write the name like this, ethane, then hyphen 1 comma 2, again hyphen diol. Okay, like that we are going to name this. Then just suppose you have this question, right? Again I have to number the carbon atoms like this. Now how many carbon are there? Butane. Now I am writing butane over here because this is word root, right? But here no substituents are there or functional group is there. That is why I am just jumping over to for writing the word root. So from word root we are going to start if no prefix or substituents are attached. So butane 1 comma 3 diene. Okay, this is the answer. I hope you have understood that in case of polysubstituted or polyfunctional group, we have to see which one is the principal functional group and which one should be written as the prefix. Okay, the principal functional group is always written as suffix, secondary suffix, and the least preferable functional group is always written as prefix. And for prefix we use different names, and for suffix we use different names. That is explained in the NCERT chart that I have shown you already in the book. In books chart it is mentioned very clearly. You have to see that. Now moving on to the nomenclature of substituted benzene compounds. Now just suppose you have a benzene ring. Now first of all, what is a benzene ring? Now any cyclic compound can't be benzene ring, right? Now benzene ring has 6 carbon atoms attached to it, and in the alternate carbon we have one double bond, means in alternate positions we have double bonds, right? This is the structure of benzene, right? It can be like this also, or it can be like this also. This I will study in resonance, that I will discuss later. So this is a benzene ring. Now just suppose you have a mono-substituted benzene ring. Mono-substituted means only one substituent is present in the benzene ring, so it is mono-substituent. Now just suppose you have this substituent, only methyl group is present. So what we will do is we will write the name prefix plus benzene. Now in the prefix, what is the substituent over here? Methyl. So we will write methyl benzene. Okay. Now in the second question, just suppose you have this OMe. Now Me is also again methyl only, right? In the short form we sometimes use Me as methyl. Now with methyl group one oxygen is present, so that is why we use the prefix name methoxybenzene. Okay, so like that we are going to name the mono-substituted benzene ring. Now this is the IUPAC name. Now the common name is toluene, right, of this, and methoxybenzene is named as anisole, right? Okay. Now just suppose you have a di-substituted benzene. Di-substituted means in 2 positions benzene ring is substituted. Again this is a benzene ring. In alternate position this is a double bond. Now here one Br group is present and one Br group is present over here. Okay. So now what to do? Now here we have to start the numbering we have to give numbers to the carbon. Here also again carbon atoms are present na? So we have to give the numbers to the carbon atoms in such a way that the substituents which are attached, it gives the lowest possible number. So here in this benzene ring, the carbon atoms can be numbered in clockwise direction or anti-clockwise direction. Okay, it can be both. So if we do in clockwise direction, right, like this, so the substituents gets the lowest number. But if we do like this, one anti-clockwise, then first one substituent will get the lowest number, but the other one will get the highest number. That is why we are going to name the benzene compounds, or sorry, number the benzene carbon atoms of the benzene ring in clockwise direction only. Like this, it is done. So in the first and second carbon, two substituents are attached. So that is why same substituents. So 1, 2 hyphen dibromo benzene. Okay, so this is how we are going to do this. Now again, just suppose you have this position, and here are two substituents attached in the benzene ring. So again we are going to number this in such a manner that two bromine atoms get the lowest possible, or substituent gets the lowest possible number. So here we will write 1,3 dibromobenzene. Okay, and again if this bromine is attached to this carbon over here, so it will become 1, 4, 1, 2, 3, 4, 5, 6, 1, 4 dibromobenzene, right? So it is like that. Now here the positions you can see 1, 2, 1, 3 and 1, 4. They have got some names. Alright, the 1, 2 position is known as ortho position. Okay, it is known as ortho position. It is very important to remember this position. The 1, 3 position is called the meta position. Okay, and the 1, 4 is called the para position. Okay, so this is how you are going to write this, right? Now if the benzene ring is tri-substituted, means 3 substituents are present, then in that case how to name it? So again, this is a benzene ring, excuse my drawing please, NO2 and here NO2, right? Now in this one chloro group is there and nitro group is there. Now again chloro and nitro are least preferable groups, but chlorine, C, it comes first alphabetically than nitro. So that is why I will write Cl first, and also you have to number the carbon atoms of the rings in such a manner that the higher priority group gets the lowest possible number. Okay, again the prefix of the substituent should be written alphabetically. Alright, so just now again we are going to start numbering the carbon atom like this. It is more good that the substituent gets the lowest possible number. So 1 chloro, 2, 4 dinitro benzene is the name, right? So again like this, this is another NO2, here methyl group is present and here chlorine is present. Okay, now again here we have to number the carbon atoms in such a manner that the most preferable functional group gets the lowest possible number, and the substituent should be named alphabetically. So first of all we have 3 substituents attached, chloro, methyl and nitro. So again chloro will be written first, then methyl, then nitro. So 2 chloro, okay, 1 methyl, 4 nitrobenzene. Okay, now there another information regarding this, that if benzene ring is attached to a chain that contains a functional group, then it is considered as the substituent and named as phenyl. Okay, if benzene ring is attached to a carbon chain like this, okay, and it is attached to a carbon like this, Okay, and then this again becomes one attached to one functional group, then the substituent is then named as phenyl. Alright, the benzene ring is now named as phenyl. Okay. So that's all for today's video. Thank you so much.